Welcome to part 1 of our series on generative visual question answering. In this video, we'll explore what generative VQA is, why it matters, and how we will approach it. Take a look at the example here. We have an image. We ask question about it, and the AI generates a human-like answer in a natural language. By the end of this series, you will be able to build a system like this from scratch. So, what exactly is this VQA or visual question answering? At its core, it's a deep learning model that takes an image and a question about it and produces an answer. There are two main types of VQA. First is discriminative VQA. Here it outputs from a set of X options, so it's more like a classification problem. Second is generative VQA. It's much more flexible and produces free-form human-like answer. Let's now compare both the approaches. So in simple term, we can say a discriminative VQA is a classification problem as it need to choose from fixed set of options like yes or no, or it could be some numbers or some choices. Basically, depending upon the task we are trying to solve. While when you compare it with generative VQA, it need to output a full sentence that describe the image. This makes it open-ended and much more closer how humans describe what they see. So in simple terms, we can say generative model provide answers that are context-aware and expressive. Why is generative VQA so important? Think about its real-world application. In hospitals, it could help us to find anomaly in an X-ray. In autonomous driving, it could answer questions like what's blocking the road ahead. For accessibility, generative VQA can help visually impaired users understand photos in real time. And in image search or captioning system, it allows richer, more descriptive result. The flexibility and contextual understanding is what makes generative approach so powerful. Building a VQA is not that easy. It comes with its own challenges. So first of all, it need to have a detailed visual information and understanding of the object, actions, and scene that are present in the image. After that, it must grasp the linguistic context of the question and align it with the image. This requires fusing image and textual information in a meaningful way. And at last, the generated answer must be grammatically and semantically accurate. And achieving all these is the core challenge we are addressing in this project. So what would be our approach to tackle these challenges? In this project, we are going to combine two powerful models. And these are, first of all, we are going to use clip to extract rich embeddings from the image, capturing the visual information in a way that can be interpreted alongside text. Next, we have GPT-2, which is normally used for text generation. Here it will be used to encode the question into embedding that align with the clip features. We then fuse image and question embedding to generate a coherent human-like answer. This approach let us bridge vision and language into a single pipeline. This wraps up our introduction and the problem overview. In the next video, we'll dive deeper into the theory and architecture behind CLIP and GPT-2. We will see exactly how the embeddings are combined and what architecture choices we are going to make. And after that, don't forget to subscribe and follow the playlist to catch all the upcoming videos. Let's get ready to bridge vision and language one step at a time. So thank you. Have a nice day.